to do is this. You need to make sure that you divide everything by 4. So we are going to divide every single term by 4, okay? Now, another thing that I want you guys to do is this. That leaves us with x squared plus 2x minus 21 over 4 equals 0. Now, the 21 over 4, you do not want to turn it into a decimal. If it does not go into 21 evenly, you just leave it as a fraction. Do not turn it into a decimal. 21 divided by 4, you cannot reduce that. Sometimes, you just want to leave it the way it is. Now, what I want you to do now is when you are completing the square, remember, you always want your variables on one side, your constant on the other side. So I am going to move over the 21 over 4. Whatever you do to one side, you must do to the other side. Now, we end up with x squared plus 2x plus something equals 21 over 4. Now remember, you have to figure out what that something is. Now, we want to turn this into a perfect square trinomial, which means we are going to, part of completing the square is you have those parentheses squared. Now, in order to put something in here, all you have to do is this. You look at the variable of your last term, and that is x, okay? Now you look at your 2. You take half of 2, and that is 1. That's a positive 1. Now, you take that 1 and you square it. 1 times 1 is 1. So I put it there, and I also have to put it here. So remember, you're going to have to combine 21 over 4 plus 1. So I'm going to do a little bit of math over here. However, if you're still wondering how I got this one right here, remember the formula, b squared over 2. So sorry, it is not b squared, it's b over 2 squared. My b happens to be 2. 2 divided by 2 is 1. And then 1 squared is 1. That's how I got that. So I'm going to do the math over here. 21 over 4 plus 1. Now remember, when you add fractions, the denominator has to be the same. So because my denominator is 4, I know that my denominator over here also has to be 4. But because I want to get 1 here, 4 divided by 4 is 1. So that right there is the exact same thing. It's just 1. Now, since you have a common denominator, my denominator is 4, you guys can go ahead and add the numerators. 21 plus 4 is 25. So on this side of the equation, you have 25 over 4. So just like what we've done prior, you want to find out how to get rid of a square. So in order to get rid of a square, we square root it. So whatever you do to one side, you must do to the other side. Now, when you square root something that is being squared, whatever's inside that parentheses comes out. So this is going to be x plus 1 equals. Now, on the other side, please don't forget, it's going to be plus or minus. Because it's a fraction, I'm going to make it a fraction bar. The square root of 25 is 5. The square root of 4 is 2. So now, you've got to solve for x. So that means you guys are going to subtract 1 from both sides. Now, because I ran out of room, I'm just going to do this. I'm left with x equals -1 plus or minus 5 halves. Now, because we have a 5 halves and we have a -1, you've got to combine them. So I'm going to break this up into 2 parts. This is going to be -1 plus 5 halves, or x equals -1 minus 5 halves. Remember, there's a plus or a minus 5 halves. Now, you have to have common denominators. So you're going to have a -2 over 2. And the reason why I chose 2 is because my denominator over here is 2. When you add those two things together, my denominator is 2, but my numerator is 3. So that's your very first solution. Now on the other side, once again, I need to have this -1 be with a denominator of 2. So a -2 divided by 2 is a -1. And then over here, I end up with my denominator's 2. -2 plus a -5 is a -7. So your answer will be 3/2 or -7/2. All right, so that's that one. Let's move on to the next one. Now the next one, if you notice, the A value is 3. You cannot start doing this problem unless your A value is 0. Not 0, my bad. It's supposed to be 1. All right, so to make my A value 1, I need to divide everything by 3, okay? So I'm going to divide every single thing here by 3. So you end up with x squared plus 2x minus 2/3 equals 0. Now remember, when you're completing the square, you want your variables on one side, your constant on the other side. So that means I need to move over the 2/3. So I'm going to add 2/3 to both sides of the equation. And I'm left with x squared plus 2x plus something equals 2/3. Oops, I wrote that down wrong. 2/3. All right, I saw it. I'm like, oh no, I wrote it down wrong. All right, so now remember, you're going to turn this into a perfect square trinomial, which means you got to figure out what this is here. And I'm going to show you how to do that. But when you're completing the square, you need to have a parenthesis squared. So in order to find out what goes inside here, you take your first term and you square root it. X squared is just x. When you square root x squared, it's just x. Now you look at your b value. Your b value is 2. 2 divided by 2 is 1, so 1 goes here. Now you take that 1 and you square it, and that goes here then. 1 times 1 is 1. If you add 1 here, you must add 1 here. So I'm going to do some math again over here. Because I have a fraction adding to a number, I need to make that number a fraction. So I know the denominator's 3, and I know that 3 divided by 3 is 1. So this is technically this, it is the same thing. So now that the denominators are the same, which are 3, I know that 2 plus 3 is 5. So that is going to be 5/3. All right, now this one could be a little bit tricky because we're going to have to do a little bit of extra stuff. So in order to get rid of a square, we need to square root both sides. So we are going to square root this side, and you're going to square root this side. Now when you square root x plus 1 squared, you're going to get x plus 1 equals plus or minus the square root of 5 over the square root of 3. Now remember, from a long while ago, you're not allowed to take the square root of, you're not allowed to leave a square root in the denominator. So I need to rationalize the denominator. So on this side over here, I'm going to rationalize the denominator. I'm going to just multiply it by the square root of 3. All I'm doing is just manipulating it. That's all I'm doing. So I end up with x plus 1 equals plus or minus square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is just 3. Now in the numerator, the square root of 5 times the square root of 3 is the square root of 15. So now I'm good. I need to get x by itself. So I'm going to minus 1 from both sides. And your answer is going to be left with -1 plus or minus the square root of 15 over 3. Now, you don't have to do anything else. That is your answer. You're done. Finished. Now, I do want to show you that sometimes, depending on what the answers are given to you, this is also a possible answer, okay? So, one of the possible answers could be this. because in reality, that's just -1. I mean, this could be a possible answer. I'm not saying that it would be. But if you don't find this in the answer solution, like, the answers of your homework, it could be rewritten as something like that up there. Because remember, 3 is the denominator. -3 divided by 3 is -1. So it's just depending on how the answers are given. All right, let's do the next problem. On this problem, once again, my a is not 1. I need to make it 1. So I'm going to divide the whole thing by 2. And I'm going to get p squared minus 1p plus 3/2 equals 0. Because they want me to complete the square, that means I need to get rid of the 3/2. So I am going to subtract 3/2 from both sides. And I'm left with p squared minus p plus something, we don't know what, and then this side is -3/2. Now, remember, you're going to have a parenthesis squared. The variable is p. We are going to take half of 1, which is just 1/2, okay? It's negative because that's negative. Once again, if you want to see what I'm doing over here, I can show you. My b is -1. So when I go to square this, I get -1 squared, which is 1. I get 2 squared, which is 4. So that means I'm going to add 1/4 here, and I'm going to add 1/4 here. All right, so remember, to get this one, it's just you take your b value and you divide it by 2. I just can't divide 2 into 1, so I can't do anything with it. Now, on this other side over here, I have to add up the fractions. So I have a -3/2 plus 1/4. I need to make sure that I have a common denominator. My common denominator is going to be 4 because 2 can go into 4 and 4 can go into 4. Now I have to manipulate this. When I multiply this denominator by 2, I get 4. If I multiply the denominator by 2, I've got to multiply the numerator by 2, which gives me -6. I don't have to do anything to the second fraction. Now that the denominators are 4, I just add up the numerators. -6 plus 1 is a -5. So this is going to be -5/4. Now, in order to go ahead and get rid of the square, I square root both sides. So you're going to be left with p minus 1/2 equals plus or minus the square root of -5 over, now the square root of 4 is 2, okay? So I'm left with p minus 1/2 equals plus or minus the square root of -5 over 2. Now remember, we can't have a negative under the radical. We all know that the square root of -5 is the same thing as the square root of -1 times the square root of 5. We know that the square root of -1 is I, and we cannot square root 5. If you forgot, whoops, my bad, tried to write outside the lines. If you forgot this important information, the square root of -1 is always equal to I squared is always equal to -1. So those, just in case you forgot, they're right there for you. All right, what I'm going to do now is I need to get p by itself. So I'm going to add 1/2 to both sides. Now the terms are different. One has a radical, one doesn't. We cannot combine them. So I'm going to get 1/2 plus or minus the square root of -5 all over 2. And that would be your answer. All right, let's get to doing the next one. I tried to make it so the videos aren't that long. And okay, we only have 2 more left. Perfect. Now here it says simplify the terms of an equation before solving. Now, this one's kind of tricky. You must distribute the x. You must turn it in. Right now, it is not a perfect square trinomial. It's really not, you can't solve this because it's not set equal to 0. So the first thing you're going to have to do is you're going to have to make this into a quadratic equation where it's going to have x squared, whatever, a linear term if there is one. So you're going to have to actually expand this. So x times x is x squared. X times 9 is 9x. Plus something. We don't know what that something is, but we know that I need to keep the constant on the other side. So now, on this problem, I personally would do this problem using the quadratic formula because I don't like fractions. So I'm going to be a little rebellious today. I am not going to use the quadratic formula on this problem because remember, you can do anything you want when you're solving quadratic equations. I personally never do the quadratic, I never complete the square if my b value is an odd number because it makes life miserable if you do. So what I did is I distributed the x squared. You know, the x times the x gave me x squared, x times the 9 gave me 9x. Because 9, which is my b value, is an odd number, I'm not going to waste my time doing completing the square because I'm going to have to add fractions and I don't want to deal with fractions. So I'm just going to solve it using the quadratic formula. But to use the quadratic formula, I need to move over the 1. So now I have x squared plus 9x minus 1 equals 0. So remember from the lessons prior, to do the quadratic formula, I'm thinking if we've done the quadratic formula yet. I don't think we have. So guess what? We have to do the quadratic. We have to do completing the square. Darn it. Let me go back to doing what I was going to do. I just was going to try to save us some time, but it's okay. Just keep going, Miss Babcock. All right. So we have x squared plus 9x plus something. We don't know what, but we're going to find it. We might not like it, but we can do this. All right. So we have something squared. First of all, when I square root x squared, I get x. You guys, I cannot take half of 9. It's just going to be 9 halves. Nothing I can do about it, you guys. I just got to leave it as 9 halves. Now, I can square 9 halves, though. 9 times 9 is 81. 2 times 2 is 4. So if I add 81 fourths here, I've got to add 81 fourths here. If you're wondering how I did that, once again, it's b over 2 squared. My b is 9. I can't divide 2 into 9. Do not give me 4.5. You do not want to turn it into a decimal. Leave it as a fraction. Now, when I square this, I get 81 over 4 because 9 squared is 81, 2 squared is 4. That's why I put that here and I put that here. So now what you need to do is you got to figure out what 81 divided by 4 plus 1 is. So I'm going to do the math over here. 1 plus 81 over 4. Remember, in order to add fractions, you've got to have a common denominator. I don't have to do anything with the 81 over 4, but I do have to do this. In order to get 1, I need 4 over 4. Do you all believe that's just 1? Now, since my denominator is the same, which is 4, I just add the numerators up, and that is 85. So over here, it's going to be 85 over 4. Now, in order to get rid of the square, I square root both sides. Remember, when you square root something that is being squared, whatever's in those parentheses come out. So that's going to be x plus 9 halves equals plus or minus. Now, you cannot square root 85. However, you can square root 4. That is 2. Now, your goal is to get x by itself. So I'm going to minus 9 halves from both sides. And you're left with x equals negative 9 halves plus or minus the square root of 85 over 2. Now, I don't think there's any numbers that can go into 85, so that's it. That would be your answer. You're finished. All right, one last one before we're done. Same thing with this one. we must do the completing the square. You have to multiply those two binomials together first, then bring the 1 over, or you can just leave the 1 over there and go from that part. By the way, I know that this is not going to give me a perfect square trinomial because they're not the same number. If these were both x plus 6's, x plus 6, then we'd be good to go. But they're not, so it's not going to work. So I'm going to go ahead and multiply these two together. Multiply these two together. I'm just expanding it. That's all I'm doing. Multiply those two together and multiply those two together. Equals 1. Don't forget the 1 on the other side. Now what you're going to do is you're going to combine like terms. I have x squared plus 8x plus 12 equals 1. Now remember, I want the variables on one side and the constant on the other side. So I am going to move this 12 over, and I'm going to try to make this a perfect square trinomial. I always put that plus something. Remember, a negative 12 plus 1 is a negative 11. All right, so here we go. I am going to make my little parentheses like we always do. My variable I know is going to be x. I know that half of 8 is 4. And it's a positive 4 because that's a positive 4 there. Now, in order to tell me what goes here, I just take that 4 and I square it. That gives me 16. If I put 16 here, I've also got to add 16 over here. So on this side of the equation, I get 5. Now, in order to get rid of the square, I square root both sides, and I get x plus 4 equals plus or minus the square root of 5. Remember, your main goal is to figure out what x is, so I'm going to minus 4 from both sides. And you're going to be left with x equals negative 4 plus or minus the square root of 5. And you're finished. That's your answer. And I believe that